Good day to all. Okay, today we will start with tutorial 1 for the chapter 1 of static in particles for subjects of applied mechanics. Okay, so for the first question, it's about the car being pulled by two forces. The force is pulled from point A, namely B and C. The B is 4 kilonewton, AC is 2 kilonewton, and then the angle is given 30 degree, and for the AC is 25 degrees. So here we want to solve using two laws. Okay, first is parallelogram law, then second is triangle law. Okay. Okay, so first we draw the free body diagram here. So here.
Okay, so the question for tutorial 1, question 1 is the car A being pulled by rope B and rope C. Rope B given by 4 kilonewton at angle of 30 degree. Rope C given by 2 kilonewton at angle of 25 degrees. So now we are going to solve using the parallelogram law. So for parallelogram law, we will solve the forces according to the axis. So here for AB 4 kilonewton, the forces that given cos 30, okay, for x-axis cos 30 plus 4 kilonewton sin 30, okay, for sin 30 it's about y-axis for force at A to B. Okay, for force along the AC, we will write in the format of 2 kilonewton cos 25, okay, cos 25 minus 2 kilonewton sin 25. Why minus? Because the force is downwards, so when y-axis it's downwards, it's a negative value. Okay, so now we written the values in force names in terms of force AB and force AC. So now we're going to return this in axis format, okay, or axis form. So when axis form fx, so when we want to put all the x-axis in one and y-axis in one. So when x-axis, here we solve for the x-axis, and here we solve for the another x-axis for FAC. Okay, this one FAB, this one FAC. So here this one we take from this. Okay, so along the x-axis, this is the formula or equation number 1. So for y-axis, this is the equation. So where we took this one from here. Okay, FAB y-axis and FAC y-axis minus 2 kilonewton sin 25. So this is we written as equation number 2. Okay, so now we're going to solve both the equation. So from equation 1, summation of forces along the x-axis equal to 4 kilonewton. We solve cos 30, we get value of 0.8660, okay, plus 2 kilonewton cos 25, okay, cos 25 we get value of 0.9063, okay, and then from here we solve for kilonewton times 0.8660, we got 3.464, then plus 2 kilonewton times 0.9063, we got 1.8126. Okay, this in terms of kilonewton. So when we plus both, we got value of 5.2766 kilonewton, approximately 5.28 kilonewton. Okay, so this is we solve for x-axis. So y-axis same, so we solve here minus we solve here. Okay, so we solve this 4 kilonewton times sin 30 0.5 and negative 2 kilonewton sin 25 is 0.4226. Okay, so 4 kilonewton times 0.5 it's 2 kilonewton minus 2 kilonewton times 0.4226, we got 0.8452. Okay, so 2 kilonewton minus this value, we got 1.14 1548 kilonewton. Okay, so we solve for y-axis and x-axis. So since we already get value of x and y, so now we can solve for resultant. Okay, resultant is summation of forces along the x-axis square plus summation of forces along the y-axis and square root of the answer. Okay, so we square this value and then we square root overall the number. So when we written in this format, we got value of 27.8784 for this value and 1.3225 for this value. So 404 kilonewton. Okay, so 5.0404 kilonewton is the resultant value. Okay, so resultant here we assumed along this part. Okay, when we draw the parallelogram, we assume the resultant to be at here. So from here since we already got the value of resultant, now we're going to find out value of alpha for the direction, okay, for the angle. So tangent alpha equal to summation of forces along y-axis divide with summation of forces along x-axis. Okay, so when we divide uh, for tangent alpha, then the alpha value will become 1 over tangent summation of forces along y-axis over summation of forces along x-axis. Okay, so alpha value equal to, we substitute the fy value and fx value here, 178. Okay, this is value for 1 over tangent alpha. Okay, so when we solve here, we got alpha value 12.24 degrees. That means the angle here is 12.24 degrees for the resultant value. Okay, for the direction. Okay, this is the alpha. Okay, so alpha value is 12.24 degrees and resultant is 5.404 kilonewton. Okay, this is how we solve for the parallelogram law. So now we continue with triangle rules for the same question number 1. Okay, so we draw the triangle here. Okay, for here this is 4 kilonewton and here we write as 2 kilonewton and this one we assume as resultant. Okay, so the 4 kilonewton value, here the angle given in the question is 30 degrees. So using the triangle rules, when here 30 degrees, here the value will be 30 degrees. Okay, so here the value will be 30 degrees. For 2 kilonewton, the angle given is 25. Okay, so when the angle here 25, here 30, so inside here we can get the value, which is 180 minus 25 minus 30 equal to 125 degrees. Okay, that means the value here 125 degrees. This one we going to find out. From this to here is 30. This value we had to know, and we going to find out the resultant and also the alpha value for the resultant's angle. Okay, so R for triangle rules, the formula is R equal to a square plus b square minus 2ab cos theta r. Theta r is angle of resultant. Okay, so here this case the theta r is 125 degrees. So R we going to find out. A we already known from the question. So B also we already known from question. So we assume 4 kilonewton as A and 2 kilonewton as B. So we substitute the value 4 kilonewton square plus 2 kilonewton square times 2AB. Okay, 2 times A is 4, B is 2. 4 to cos 25. Okay, so now we solve for this value. So cos 25 is negative 0.5736. Okay, so when r equal to, when we solve here 16, we solve here 4 minus 16. Okay, we solve here, we got 16, and then at the bracket negative 0.5736. So now we got value of 20 plus 9.1776 here, and R equal to 5.401 kilonewton. Okay, this is similar to the answer that we got from parallelogram law method, which is 5.404 kilonewton. So here it is 5.40. We use this formula, B over sin B equal to R over sin theta R. Okay, so here B is 2 kilonewton, sin B we going to find, R we already know from here 5.4, and sin theta R is sin 125 degrees. Okay, this value. Okay, so from here we substitute the values. So sin B equal to 0.8192 over 5.4. Okay, so sin B equal to 0.3034. So B equal to 1 over sin 0.3034. Okay, this sign when we bring here, it will become 1 over sine. Okay, when this sign we bring here, it will become 1 over sine. So it 1 over sine times this value. So we got value of what, 17.66. That means this is B, this beta value is 17.66. We already know this overall value is 30, so beta value we know as 17.66. So 30 minus 17.66, we will get value of alpha here. Okay, 12.34, this part.
Okay, so now second question of the tutorial 1. So here two forces are being applied at the point of B. Okay, 2 kilonewton and 3 kilonewton. Angle is given 60 and 40. So same here, using the parallelogram law and triangle rule, we're going to find out the answer. So first, for parallelogram law, we draw the parallelogram.
So now we will use parallelogram law to solve the equation. Okay, for force, we put in force in 2 kilonewton and 4 kilonewton, and straight away we put in this box, which we solve to x component and y component. So for x component, for 2 kilonewton, start with negative 2 kilonewton sine 40. Okay, why negative 2? Because the angle of the direction of the force is at left, towards the left hand side, which is negative x. This force into x-axis, it's sine 40. To solve at x-axis, so it's negative 2 kilonewton sine 40. So sine 40, we got value of negative 1.2858. Okay, this one for x-axis. So y component, in this 2 kilonewton to cos 40. Okay, because y-axis here upwards. Okay, positive upwards, downwards negative. Okay, 2. And then for force 4 kilonewton, we use 3 kilonewton sine 60. So sine 60 here for the x-axis, and sine 60 is 0.8660. So 3 kilonewton times 0.8660, we got 2.598. So negative 1.5. So when we add both the value, negative 1.2858 plus 2.598, summation of forces along the x-axis, we got this value 1.31 value, negative 1.532, and here negative 1.5. So negative 1.532 plus negative 1.5, it will become minus. So here it's 3.0 in this format, which is we already done in the previous question. So here the x-axis values and y-axis, so same value, so plus summation square root of the value. Okay, so here we do the calculation. Here this is value that we got. Okay, from value that we got, we get the value of resultant. Okay, resultant we got 3.30 kilonewton in terms of kilonewton in SI unit. Okay, so now we already got the value of resultant direction. So tangent alpha equal to summation of forces along y-axis over summation of forces along x-axis. So alpha equal to 1 over tangent, and this value we take from here. We got value of alpha equal to negative 66. Write as a 66 degree. Use this method. Okay, so here another method to solve. Okay, here it's 2 kilonewton this part, and this is 40 degrees. Okay, so according to triangle rules, so is 40 degree equal to this 40 degree. So here we got same value of this 40. Okay, so when here we got the resultant value. Okay, since the calculation for the resultant equal to a square plus b square minus 2ab cos theta r is resultant's angle. So resultant's angle we already know 80 degrees. So we substitute all the values. A is 2 kilonewton, B is 3 kilonewton. Here is cos theta r 80 degrees. So when we calculate all the values, we got value of r equal to 3.30 kilonewton. So from here we going to find out angle direction. B over sine beta equal to r over sine theta r. So 3 kilonewton over sine beta equal to 3.30 kilonewton over 80 degrees. Okay, it's supposed to be sine 80 degrees here, sine 80 degrees. So sine beta equal to 3 kilonewton. This is value of, we got this value, and 1 over sine of for this value we got 63.54 degrees. So beta value we already know 63.54 degrees. So now we're going to minus the value of overall values here to get the alpha value. So alpha plus beta plus 50, because this beta overall this part. Okay, so equal to 180. So alpha equal to 180 minus 50 minus beta. Okay, so beta is including this value plus 40. So 180 minus 50 minus 63.54. Okay, where we got this value here. Okay, this value beta, so it's equal to 66.46. Okay, so this resulted with our previous calculation. Okay, so now we are moving to question number 3. So here a bit different from our previous two question in this tutorial session. So here we got three forces, F1, F2 and F3. So now we write F1, F2 and F3 in terms of their forces. So F1 is 900I. Why we use I here? So it's when it involves three forces or three axes, we will use Cartesian vector format. So Cartesian vector format will include I, J and K components. Okay, so here it's 900I for the x-axis here. For F2 it's a 750 Newton is given. For x-axis is cos 45. Okay, here the cos 45 is given, and I. Okay, and then plus 750 Newton sine 45. Okay, for the 45 degrees, when solved into y-axis it will be sine 45 J. Okay, y-axis J, x-axis I. And for F3 they give here theorem Pythagoras. So from theorem Pythagoras we're going to write in terms of theorem Pythagoras. Okay, for x-axis 4 over 5. Okay, 4 over 5, 650 Newton I. Okay, if you see here the direction here it's positive. Okay, that means the arrow here is inwards, so here it's positive. Okay, so y-axis it become negative because it's downwards. Okay, the direction of the forces very important. Okay, here these two are going outwards, here it's going inwards. Okay, so now we already write in Cartesian vector format. So now we're going to solve. Okay, so F2 equal to cos 45 times 750, we got 530.33i, and 750 times sin 45, we got 530.33j. For F3, we solve here, we got 520i minus 390j. Okay, here 1 times 5, here 130 times 5, 650, 4 times 130, we got 520. Okay, on 130. Okay, here 1, here 130. Okay, so this is the value we got. So now we already got in terms of I and j. Okay, so now we write in x-axis format in summation of x-axis. So 900i plus 530.33i plus 530i. Okay, so this is value we got for the x-axis when we plus all the values, and for y-axis we got value of for y-axis. Okay, this we solve, then we got value of this 530.33 j minus 390 j. Okay, so we got 140.33 Newton. So now we already got value of x-axis and y-axis. Now we want to find resultant, so we use this formula. We substitute when we square and use answers. Okay, so when we solve this, okay, we get value of 1955.37 Newton for resultant. So now we're going to find value of alpha. Tangent alpha equal to summation of forces along y-axis over summation of forces along x-axis. So now we substitute the values from here and here, and then when we do the calculation, the tangent when we bring here, it will become 1 over tangent. And this value we solve, we got alpha equal to 4.12. So when we start to draw here, alpha equal to 4.12 and resultant is 1955.37 Newton. Okay, this is the value.
So here fourth question. So here force 1, force 2, force 3. Okay, 3 forces are.
Okay, so now we go for the solution number 4 for question 4. Okay, so in the question given 3 forces F1, F2 and F3. So 3 forces here. So again we will use Cartesian vector format for this question. So when Cartesian vector format, it will involve I and j terms. Okay, so F1 they give theorem Pythagoras, F2 they give 15 degrees angle, and F3 along the x-axis. Okay, so for F1 we will write in terms of theorem Pythagoras, 3 over 50i plus 4 over 5 50j. For F1 it will be when we cancel here, it will be 10 times 3 30, cancel here, it's 10 times 4 40. And for F2, the value for x-axis is towards left, so negative, and y-axis towards downwards, 80 Newton, sine 15, and negative 80 cos 15. Okay, cos 15 for the y-axis, sine 15 for the x-axis. Okay, so F2 when we solve, sine 15 gave this value 0.2588, cos 15 give 0.9659. So when we do the calculation, we get in I and j terms, which is negative 20.71i minus 77.27j. For F3, it's only involves x-axis, which is positive 30 Newton, so 30i. Okay, so after this we will put x and x-axis, summation of forces along x-axis, 30i minus negative or minus 20.71i plus again another 30i. Okay, and then for y-axis 40j minus 77.27j. Okay, so value when we do the solving this, we get 39.29 Newton, and here negative 37.27 Newton. So since we got x and y value, now we going for the resultant force finding. So resultant equal to summation of forces along x-axis square plus summation of forces along y-axis square and square root of the answer. So when we substitute the value, we got 54.15 Newton as answer. And then for angle, we will use tangent alpha. So summation of forces along y-axis over summation of forces along x-axis. So we got angle 3.49 degrees. Okay, negative 43. So when negative 43, it lies in the fourth quadrant of the circle. Okay, so when fourth quadrant, it involves something this area which is 43.49 degrees. Okay, which involves in this area. Okay, this is the area which involves the angle.
Okay, fifth question of the tutorial. Okay, so here they're using three axes and three forces, x x here, y here, and z here. Okay, unusual from normal, x, y, and z. So each measurement is given, and the tension of the cable is said to be 385 Newton. Okay, uh, so now we're going to find out BD and BE. Okay, so the value is given 385. So now we're going to find BD and BE, and then the magnitude and coordinate for the angles alpha, beta, and gamma of the resultant force. Okay, first BD and BE we draw like this, and then we do the calculation 385 Newton. Here the negative 180 is because the x-axis towards this part. Okay, here the x-axis here is positive, here is negative, so negative 480, and then plus 510. Okay, so j is y component, so this 510 is positive. Okay, then negative 320k. Okay, negative 320 is for the z-axis. That means this 600 minus 280, so you will get negative 320. Okay, and because this part is from here to here, that means from positive to negative, so it will become negative 320. Okay, so we compute, we put in a Cartesian vector form, we got this value. And then for TBC 385, and then for this one negative 270. Okay, 480 minus 210. Okay, 480 minus 210, we got value of this, so this value we got 270, negative 270, because its x-axis is here positive, here negative, so from here to here it will be negative. Okay, and then positive 400J, so the length from origin to y-axis 400 towards positive, and then negative 600k. Okay, that means this whole length negative 600, because it's from 0 to here positive, but in this case it's from here to here. Okay, so it's negative 600, here to here negative 600, so we compute, we got this value. And then how they do the calculation. Okay, and then
Okay, for TBD, we will do the tension at along rope BD. So BD 385, the tension that given, negative 480I. Okay, because it's opposite direction of the x-axis, so negative. Positive 510J. Okay, because y-axis positive, and the z-axis is 600 minus 280. Okay, the overall length is 600, then minus 280 we will get z-axis, and also in negative value because in opposite direction, the force acting on the opposite direction, k. So here down here we put again these values and square, okay, and then square root overall value. So when we do the calculation, we got this value, and this value actually we can cancel with here. So when cancel 385 over 770 we get half, okay. So from half we can cancel this, okay. So here 240, here 255, and here 160k, okay. So TBD will be negative 240i plus 255j and negative 160k Newton, okay. So for TBD this is the value, and for TBC the value will be from 385, same again. And for the x-axis we need to minus 480 minus 210, okay, the midpoint there, which will get 270. Front here negative because opposite direction, positive 400j along the y-axis, and negative 600k because opposite direction of the z-axis, okay. So again same method, we do the calculation, again got 770, 385 over 770, we got half. Then when we cancel we got 135, 200 and 300. So now we got value for the TBD and TBC. So when we got value for TBD and TBC, now we can compute for the summation of value for the tension in TBD and TBC, okay. So we will plus this value from here, we put here, and then plus with this value, okay. So I and I will be sum up, j and j will sum up, and k will sum up. So according to here we got negative values here, negative 240 plus negative 135, okay. So negative 240 minus 135 in I, and then 255 plus 200 in j, and negative 160 minus 300 in k, okay. So when we do this calculation we get this value, negative 375i plus 455j minus 460k in Newton, okay. So now to find resultant we need to square x, y and z. So now we got value in x, y and z. So we will do calculation for the resultant. So negative 375 square plus 455 square plus negative 460 square. So value is 559250, okay. And then we square root the total, we got 474.83 Newton as a resultant tension, okay. Since we got resultant, so now we can find for the angle, okay. So for alpha is cos alpha equal to tx over tr, cos beta equal to ty over tr, cos gamma equal to tz over tr. So when 1 over cos here we put the value, so x is negative 375, okay. So negative 375 is x value, so we put x value here, and the resultant value here, y value resultant value, here z value resultant value, okay, x, y and z. So we substitute here, then alpha we got 120.10 degree, beta we got 52.52 degree, and gamma we got 127.96 degree.
Okay, so the next question, number 6. Question number 6. So here the tension is given for the values AB and AC. So AB is 510 Newton, AC is 425 Newton. So if we are going to find the resultant and the magnitude for the forces exert from the A, okay, for the angle and also the magnitude. So the final answer will be this. Okay, so first for AB and then for AC. So for AB, how the value is being calculated, x is here, y here, z here. So x will be positive y will be negative, z will be positive. Okay, how we going to compute? And for the AC, x positive, y negative, z positive.
Okay, for the question 6, the solution, we're going to find the solution. So here TAB and TAC given. TAB is 510 Newton, TAC is 425 Newton. Okay, so now we go for the TAB first. So TAB 510, 40I, negative 45J plus 60K. Okay, here the value is negative because the y-axis is negative, and we do the calculation here again, same. So when we do this calculation, we got 7225, and then when we 510 over this value, we get 85. Okay, 7225 square root of this value, we got 85. Okay, so we can cancel here. We got 6 over 1. Okay, 6. So when 6 times 40, 6 times 45, 6 times 60k, we got 240i, negative 270j plus 360k Newton. Okay, in TAB. Okay, now TAC. TAC is given 425 Newton. So the x-axis should be 60 plus 40 mm. Okay, so here we get 100, negative 45j plus 60k. Here again the 45 is negative, y-axis is negative. Okay, so now we do the calculation. We substitute the values. So here we got 15625. Okay, so square root of this value, we got 125. Okay, so for 125, we when we cancel, we got 3.4. Okay, that means 1 over 3.4, 3.4 over 1. Okay, so 3.4 times this value, we got 340i. 3.4 times negative 45, we got negative 153, and 3.4 times 60, we got 200 kilo k. Okay, not kilo, sorry. Okay, so summation of tension TAB plus TAC. Okay, so this value plus this value, we will get we will do the write up in the TAB and TAC. So now we put all I, J and K. Okay, this TAB, this TAC. So when we sum up, I and I we will plus, J and J we will plus, K and K we will plus. Okay, so when we do the calculation, we got final value 580I minus 423J plus 564K. So for resultant, we need to find x, y and z. So we already got x, y and z. So we substitute here. So we got this value. When square root, we will get 512.92 Newton as a resultant. So for alpha, again the cos alpha equal to Tx over Tr, cos beta equal to Ty over Tr, cos gamma equal to Tz over Tr. So when cos come here, it become 1 over cos. So when substitute the values, we will get this angle. Okay, when do the calculation, you get this angle. So 50.51 degree, beta is 117.63 degree, and gamma is 51.81 degree. Okay, this is the answer for the question 6.
For the tutorial one, it's a seventh question. So here also same, force 1, force 2, and x, y, and
Okay, for solution question 7, so the forces are given in two, force 1 and force 2. So force 1 is 450 Newton from question, and force 2 is 525 Newton from question. For force 1, they give theorem Pythagoras, while for the force 2, they give angle for each direction. So here the forces involves two forces, two variants, and three axes. Okay, so when involve three axes, we will use Cartesian vector form to solve. So for the first one, I is 0. Okay, so we just calculate for the j and k. Okay, for the j, it's a 3 over 5 times 450 minus 4 over 5 450. Okay, 270j. Okay, we cancel here, 1 times 5, and here 90 times 5, so 3 times 90, 270, here 1, here 90, so 4 times 90, 360. So we got in terms of j and k for first one. So now for first two, they given value 45, 120 and 60. So for the first two, x-axis we will use cos 45. Okay, cos 45 in positive, which is in x-axis, and for the uh, y-axis it's a negative 120 degrees. Okay, because the value is negative. Okay, the y value is negative, so here we suppose here negative, we put here, so sin 120, and then for the z value it's cos 60. Okay, we want to solve for the x, y and z axis. Okay, so solve here, 0.7071, solve here we got negative 0.8660, and solve here we got 0.5. okay, so now we do the calculation, we got this value. So first one and first two we get to know already. So from here we will do the resultant, we will need to find the resultant. So before that we will do the summation of the forces. So first one plus first two, okay, summation of forces, 270, this one, minus 360, okay, this value plus this value. Okay, so here, so now we will put I, j and k values. So we got 317.23 minus 184.66 j minus 97.5 k Newton. Okay, so now we going to find for the resultant, fx known, fy known, fz known, values from here. So we will substitute, and we got 379.79 Newton as a resultant force. Okay, and from calculation for the angle, so alpha equal to cos beta, gamma equal to cos 1 over cos dz over dr. So when substitute the values, we get alpha equal to 33.35 degrees, beta equal to 119.09 degree, and gamma equal to 104.88 degrees. Okay, this in value of direction. So here the resultant force, here are the direction.
For the question number 8, the final question of tutorial 1, FB is given 560 Newton and FC is given 700 Newton, and then now we're going to find the resultant magnitude and also the angle.
So here the given forces are FB 560 Newton and FC 700 Newton. So here we're going to find forces in I, J and K format for the Cartesian vector format. So FAB will be 560, and the x-axis is 2I, positive 2, y-axis is negative 3J, and z-axis is negative 6k. Okay, y and z here will be negative, and then here square of the values, and then we square root overall total. So 560, when we do this calculation, here we got 49, 4 times 9 times 36. So out of 49, when square root, we got 7. So 7 cancel with 560, we got 80. So 80 times 2, 80 times 3, 80 times 6, we got 160i, my negative 240j and negative 480k. Okay, for the value of FAB. So once we find FAB, now we're going to do calculation for the FAC, 700 Newton given, and then 3i plus 2j minus 6k. here x and y are positive, only z is negative, so here negative 6. Okay, then we do the calculation, and then we square root, got 49 again. So 700 over 7 got 100, so 100 times 3, 100 times 2, and 100 times negative 6. So we got 300i, 200j, and negative 600k Newton. So once we got FAC and FAB, now we are going to sum up FAB and FAC. So when we sum up this one FAC, here FAB, here FAC. So when sum up 160 plus 300i, negative 240j plus 200j, negative 800 480k minus 600k. So we got 460i minus 40j minus 1080k in Newton. So now we're going to find out the resultant. So fx square, fy square, fz square, square root. So we replace the values here, then we got this value 1379600, and then square root we got 1174.56 Newton. Okay, so now we already got the resultant force. So next we're going to find out the angle alpha, beta, and gamma. So for angle alpha, it will be fx over fr, 1 over cos, and then when we do the calculation here, it will gives we substitute here and here, and when solve here it will give 0.3916. so 1 over cos for 0.3916 we got 66.95 degrees, and then fy over fr resultant. So when we solve here we got negative 0.0341, so negative 0.0341, 1 over cos we got value of 91.95 degrees. And then for gamma value, 1 over cos fz over fr. So when we solve here we got negative 0.9194, so this value times 1 over cos we got 156.84 degrees. So the resultant value is here, and these are the angle value that we got from this calculation.